Hi all, let's talk about today's problem. Our problem name is count pair sum in matrix. So here we are given a two matrix mat1 and mat2 of size n into n, right? So in this case, both the matrix they are in the sorted order. They are in the sorted order, right? And from left to right and top to bottom. Our task is to find all the pairs. We have to count all the pairs of the number for both the matrices. Those sum is equal to x. Those sum is equal to x. Let's talk about its first example. Here we have n equal to 3 and x is 21, right? In the mat 1, we have these elements, and mat 2, we have these elements. Its output is 4, right? So let's understand the problem first. This is the matrix 1, right? This is the matrix 1. This is the matrix 2. So question said it's in sorted order. So if in the sorted order, the first approach which came to my mind is we make two vectors v1 and v2. In this part, I am storing all the values of it. I am storing all the values of it as it's in the sorted order. 1, let's store 1, 5, 6, 8, 10, 11, 15, 16 and 18, right? And in v2, the same approach we have to do 2, 4, 7, right? 9, 10, 12, 13, 16 and 20. So we have two vectors v1 and v2 which in the sorted order we have to count all the pairs from both the matrices. Those sum is equal to x. So it's very simple question. We have to use here two pointer approach, right? The first pointer is pointing to this and second pointer is pointing to the last index of v2, right? So we have to go in the manner like if the sum is equal to x, like here our x value is 21. If it's equal to x, like here we have 1 plus 20 as a pair, it's equal to x. So we have to count. Our count is plus plus, count is 1 now, right? And in this case we have to move forward. We have to move forward in both the cases. We have to move forward. In this case we have to increment it. Here we have to decrement it because 1 and 20 are taken that pair. So what's the approach here? Let's write a pseudocode here. If sum of 2 equal to x, in this case let's write here if sum of pair ठीक है equal to x, in this case we have to increment our count because we got a first pair and our first pointer is increment and second is decrement. Let's suppose it's a low. Here we are using low pointer, here we are using high pointer. Okay, so let's go forward. 5 and 16 we have, 5 and 16 we have. In this case again we are encountered with the target, right? So our count is 2 now. We are in this if condition. Let's move forward. Now our low is pointing to this and high is pointing to this. In this case we have a sum. We have a sum 6 plus 13 which is 19, which is less, but we want more to reach 21. It means that we have to increment our low. In this case, we have to increment our low, right? Only low. Let's write here else if sum is less than x, we have to increment the low, right? So now we have 8 and 13 as a pair which is 21. Let's write here 8 plus 13, we got a pair which is 21. Let's increment the count which is 3 now, and in this case our low is pointing to here and our this is pointing to this place. In this case we got 10 and 12 which is 22, right? Which is greater. Now we have to write again a case else when sum is greater than x, we have to decrement the high pointer. ठीक है? It means that we have to reach this place. We have to reach this place. Here we have 10 plus 10, which is 20, which is less than x. So in this case, we have to go. It means we have to increment the low. Okay? We have to increment the low in this case. It means low is pointing to this now. So this is also a valid pair. 10 plus 11, which is 21, and increment the count, which is equal to 4. And in this case, both are pointing, both have to change. Both have to change, pointing to this, and this is pointing to 9 now. As you see, now we have 15 plus 9, which is 24, which is greater. So we have to decrement our high pointer. Okay. Now we are reaching to this part. So we have 15 plus 7, which is 22. Same case, we have to decrement our height because we need less. We reach to this 15 plus 4, 19, right? 19. In this case also, but in this case, we need 21, which is more. In the more case, we have to increment the low part. Okay. We are incremented low. So we have 16 plus 4, which is 20. Again, it's less. We have to increment our low. So low is pointing to now 18, right? So 18 plus 4, which is 22, right? In this case, we have to decrement our high. So now high is pointing to 2. In this case, 18 plus 2, which is 20. Again, it's less. We have to increment the low. So low is out of bound right now. So we have to return how much count, how much pair we have till now. So which is 4. That's why our output is 4. Okay. So in this approach, as you see, we are using V1 and V2. We are using V1 and V2 as an auxiliary space. So the time complexity here is big of n square, but space we are using big of n square. Can we solve this question without using space? That's the interesting part. How we can solve. So here we have two things. We just want to change the pointers. Like in previous solution, we are taking 2 pointers, but here we have to take 4 pointers. Okay. So the first pointer, what we are doing in the previous solution, in mat 1, in matrix 1, we are pointing to the smallest element. Same case we have to do here also. So this is the smallest. Let's suppose it's R1. Here we are C1. This is row 1, this is C1, right? This is column 1. And in mat 2, we are pointing to maximum element. So this is R2, this is C2, right? So let's write down here R1 initially pointing to 0, okay, and C1 is 0, right? But right here it's n minus 1, means it's pointing to 2, which n is 3. So R2 is 2 here and C2 is 2 here, right? 2 means n minus 1. So we have this, right? Let's write down step by step code also so that you can understand it better. We have C1 pointing to 0. So R2 is pointing to n minus 1 and C2 is pointing to n minus 1, right? Right? So what's the base case? Like what's the stopping condition? As you see here, maximum we can go to this part. Okay, maximum we can go to this part, right? How we can go? Like for example, let's do step by step. We are at this point, which is 1. So its sum is 1 plus 20, which is 21, right? Just compare with the previous one. Here sum is 21. It means our count is increment. Let's suppose our count now is 1, right? So in previous case, we are increment the both the pointers, right? So here also we have to increment, but we have to increment here C1. Our target is going to 5. So in this case, we are increment C1 only. ठीक है. Now C1 is pointing to this point, C1 here, and C2 here, 16. Just compare with the previous solution, all are same, just we have to change the condition of it. So right now we are at 5 and 16, which is 21. Again we encountered with the pair. ठीक है, those sum is 21. Again we have to do it. Again we have to do the same thing. We have to increment the C1 and decrement the C2 part. ठीक है, decrement the C2 part. Let's write this code. So R1 should less than n, and ठीक है, this is the first condition, R2 is greater than equal to. ठीक है, so the sum is mat of 1 of R1 and C1, ठीक है, plus mat 2 of R2 and C2, right? This is sum. If sum equals to x, we have to increment the count part. Let's make a count here also. Count is 0, and if it's equal to x, we have to C1 should go forward and C2 go backward, right? So let's go into this place now. Now C1 is at 6 and C2 is at this place. Let's make what's the sum is. So here the sum is 19. It means it's less. Just compare with the previous. If we have a sum which is less than x, what we are doing? We increment in the matrix 1, right? It means we have to increment the C1. Let's increment it. Let's increment it. Else, if sum is less than x, we have to increment the C1. But there is a problem. C1, if we increment the C1 here, our target is going for 8 element, but we reach to this part. So how to solve this? So for this, we have to write a checkpoint. Let's write here, if C1 equals to n, means it's out of bound in that matrix, right? We have to increment our row, right? And column equals to 0. C1 should equals to 0 and increment the row. Just see this point. Just see this point. Right now, we are at this and we encountered with this statement, and our target is to reach this point. So what I am doing, just increment the row. It means that now our row is pointing to this. Now my row is pointing to this and C1 is pointing to 0. It means that we reach to our target, right? We reach to 8, right? Let's write this also. So here we have to write, if C1 equals to n, in this case C1 should 0 and we have to increment the R1, right? Hope you understand till now. So right now we are at 8, right? We are at 8 pointing to 8, and in this we are pointing to 13. Okay, we are pointing to 13. Its sum is 21. It means that we encountered with pair and we have to increment the count, and we are doing this. Okay, in this case what we are doing, what we have to do, we have to increment C1 and decrement the C2. Simple. Okay, so my C1 is pointing to this part and C2 is decrement in this case. But here also a problem came. When C1, C2 is decrement, now C2 is pointing to -1. It means it's out of bound. But my target is, what's my target? After 31, it should be pointing to 12, right? It should pointing to 12. So how we can do? Just visualize. R2 is now this. We just decrement the R2 to move forward, to move upward, right? And C2 pointing to this point. It means n minus 1. Let's write this also. If C2 equals to -1, it means it's out of bound. We have to we have to decrement R2 and make C2 equals to n minus 1, right? It's very simple. Okay. Now, in this case, my R2 is pointing to this and C2 is pointing to this. Okay, C2 here, R2 here. Now we reach to our target where we want to go. Okay, so right now I have 10, right? I am pointing to 10 here. In this case, I am pointing to 12. Now my sum is greater than x. Just compare with the previous. If the sum is greater, we have to we have to go backward in the second matrix. Okay, same case we have to do here. We have to go backward in the second case. It means now C2 is pointing to this. So let's write this also here. It will be in the else condition. Else C2 should negative, right? Now the C2 is pointing to this. It means 10. Okay, and 10. So its sum is 20, which is less. So if it's less, we have to increment C1. So we are incrementing the C1. So C1 is pointing to this now. Okay. Now C1 is at this and C2 is at 10. Okay. So 11. We have 11. Next pair is 11 plus this, which is 21. It means that our count will be increased and it reached to 4, right? And in this case, now we have to change our row in this case and column in this case. Now I am pointing to this row and column is this. Okay, and in this case we have to decrement the thing. So my C2 is pointing to this point. Okay, in this manner we count the pair sum, right? In this manner we count the pair sum. I hope you understand this intuition. Let's go forward also and let's check any pair we have its meaning or not. Now our C2 is this, which is 9 and it's 15. So 15 plus 9, which is 24, right? It's not okay, right? So decrement the C2 part here and change this part also. Now R2 is this, C2 is this. Now we have 15 plus 7, which is 22. Again, it's great. Okay, we have to decrement this part. So in this case, we reach to 4. So 15 plus 4, which is 19, right? We have to increment this. We have to increment this part. So now we are at this place. 16 plus 4, 20. We have to increment this. Now we are incrementing this part. Now we are reaching to 18 plus 4, which is 22. Again, we are not reached to our target. So now we are at this point. 18 plus 2, which is 20. Again, it's less. Again, it's less. So we are moving to this. And here what we are seeing, when we are at this point, out of bound, it means C1 equals to n. In this case, what we are right, C1 is pointing to 0 and R1 is increment. But R1 is here 2. It means that R1 reaching to n. Okay, it's reaching to n. Here is the stopping condition we are writing in the while loop. Here we have to stop. So as you see, here I am writing the while condition. R1 should less than n. Okay, and R2 should greater than equal to 0. So this is a stopping condition and I hope you understand this intuition. Let's return it and check it's correct or not. Yeah, the output is correct. Let's submit it now. So all test cases pass, and in this case we are just traversing it and we are not using any auxiliary space. So its auxiliary space is constant here and time complexity is simple n square, right? Hope you understand this question. Thank you so much.